In this example, we will eliminate the parameter t to rewrite the following parametric equations as a Cartesian equation. This can be done in a couple different ways, and I will demonstrate both methods that this can be done. It is typically recommended, though, to just go with whatever is easiest, particularly in cases when you're dealing with algebraic expressions like what we see here. We do have x is equal to 2t plus 1, and y is equal to 3 times the square root of t. If we do have a set of parametric equations here, and we're trying to get this into Cartesian, we typically do so by isolating t in either of these equations and substituting into the other. For example, I will choose first to take x equals 2t plus 1, and I will try to isolate the variable t. To do that, that just takes a couple quick steps. Subtract 1 from either side to get x minus 1 equals 2t. And then divide both sides by 2, which will give you x minus 1 divided by 2. I now have t as a function of x, and I can then therefore take y equals 3 square root of t, and I can substitute this expression, x minus 1 divided by 2, in for t. What that will do is it'll eliminate so that there is no longer any variables of t floating around, and all I will have left are the Cartesian variables x and y. So what this will look like then is I will have y is equal to 3 times the square root of x minus 1 divided by 2. And that would be my equation. I could have also done this by isolating t in the other equation instead. I could take y equals 3 square root of t and work to get t by itself here. If I divide both sides by 3, I will get y over 3 is equal to the square root of t. And then I can square both sides to get t is equal to y squared over 9, or y over 3 quantity to the second power. Then, because I have t as a function of y, I can then take my other equation, x equals 2t plus 1, and since I know that t is defined as y squared over 9, I can plug that in for all instances of t. That would give me x equals 2y squared over 9 plus 1. Both are valid ways of taking this parametric equation and writing it as Cartesian. If the question you are working with specifies to get x or y by itself, then make sure that you do so. But if you are simply just trying to convert to a Cartesian equation, either one of these would be perfectly valid.